Greetings. Today, I'm going to make a book summary. Which book are you asking? This one. It's called A Brief History of Intelligence. So, what is this book about? Simply put, it's asking this question: how can we make a better AI? Well, we can look on nature and how nature figure out intelligence and what we can learn by observing nature and learn the way the nature did it. But also, it's also about AI. By understanding how our own nature works, we can learn more about us. We can learn more about brains and how we make decisions and how we are functioning in this world. Yes, this is going to be a book summary. And it's going to be more episodes. Because in this book, he focused on five big breakthroughs of our ancestors and how they figured intelligence. And I want to make each breakthrough one separate video. Yes. Basically, this book doesn't try to explain how intelligence work in all life. It just focuses on our ancestor. So the first ancestor were by bidators, then he focused on the vertebrates, the first mammals, primates, and the last are the humans themselves. What make us special? What make us unique? We will check it out. We will find out in this book series. But let's first. I want to start also talk about the history before birds. Because in the timeline of nature, for 85% of life history, there were no birds. All intelligence was just stored in DNA. And the problem is with DNA that it's very slow, just by evolution. So there's no ability to learn. Animals behave according to their genes. And it's perfectly sufficient at the end of the day because the issue is the biggest problem that nature wants to solve is the how to get energy. When there's no energy, there's no life. When there's energy, there is a life. Yes. And how to get energy is the problem that needs to be solved. And another way is to encode it in DNA. So, like for example, photosynthesis, it was one of the brilliant idea of nature. One of the first that solved this was cyanobacteria, which create a great oxidation event. In this event, oxygen was massively in atmosphere, which creates a new opportunities. Because the plants are not smart. You don't see some intelligent plant around. They're just doing nothing. But they're doing nothing because intelligence is just one of the way to solve issue of getting energy. And for plants, it was sufficient. They get energy from the photosynthesis they created. There was no incentive to do more. And also, photosynthesis is not really that efficient. Producing energy from the sun without oxygen is like 15 times less effective than using actual oxygen the way we are getting energy. So we cannot really expect there will be some high intelligent photosynthesis monkeys or something like that. There's not possibility, and there's also no incentive. So clearly, this was not the way for intelligence. There could not be this way. But as I mentioned, in the great oxidation event, when the photosynthesis was created, there was new space because thanks to oxygen, organisms that start using oxygen for respiration they couldn't produce energy by themselves as plants, but they could stand it. They could hunt, they could fight, and they get it. And the arm race for intelligence could start it. But once again, how to get the energy, even by stealing it. Let's talk about, for example, fungi. Fungi are much more like to us animals as to plants. They breathe oxygen. They eat sugar. They don't create their own. They need to eat it from some other sources. So the strategy the fungi are using is just to wait. Just wait. The life will die. That's it. Will die, and they just yum yum. We just digest it, and that's it. That's their strategy, and work. It's successful. But for animals, it was different strategy. They tried to catch it, to kill it, and steal the energy. That was the most like fundamental way how they differentiate fungi and animals. But for that, animals need neurons to solve the problem of moving and hunting and solving. So that was the first step how to get intelligence. Because for the fungi, they have no need for neurons. They just wait. They just wait, and then they can just eat it when it's dead. So there's also another reason why we cannot expect smart fungi, because for them the strategy is sufficient. Fungi are incredibly successful. They have six more biomass than animals. So like, the strategy is better for evolution doesn't really matter. It's just a different strategy in the end of the day, and they have no incentive to build neurons and to become more intelligent. For them, this was perfectly sufficient. But all animals need neurons. The first brains, the first brains they were in multicellular life were quite different from ours. Even the animals were quite different. They need neurons just for simple reflexes. There were no thoughts or just pure reaction. If something happened, then I'll catch the animal, or the prey. So we should think about the first animals more similar to corals than something that we would normally think about animal. That's not a curious fact. Neurons are the same everywhere. If you are jellyfish or human, it's the same. It's the same. It's just the network that kind of make the difference, kind of really makes a difference. Not the cells themselves. So the neurons work the same. It's the same logic. It's like the computers, tablets, phones. The logic is the same, or like different devices. The core is the same. That's what I'm talking about. The core is the same. So how neurons work? Of course, I will not go into details. It's just introduction to the problematic. But just to send briefly, neurons don't send a continuous signal. It's more like all or nothing. It's called action potential, something similar to transistor zero and ones. They fire or they don't fire, nothing like a little bit or stronger fire. Of course, there's different sense of intensity. It's not about stronger fire, it's always zero and one kind of. But the frequency can change, so it's more about the rate itself. uh, More fast, not faster, but more times it fire, the more intensity there is. So the stronger the signal is, kind of vibes. That's kind of the thing how it works. And but there's a limit. You cannot have infinite fires. There's like around like 0 to 500 spikes per 1 second, which is kind of a lot, but not enough. Because like imagine like you're a baby and you just see the world around you. There's so many stimuli that your brain just need to observe. But after a while, you adapt. Like, when you enter a room, it's not like wow. It's kind of adapt. So some firing is just limited, and especially the new sensory information on the most important stuff hits your brain and you realize it. Some weird smell or some different light or something like that. But most of the your brain adapt. When you walk into loud room, it's overwhelming at first, but after a while, it just mutes in the background. It's kind of true for everything. Again, we can learn from this for our real life, and we taking so many things for granted as well. We just adapt to it, don't think about it. On a question of gratitude. It's so hard to be grateful for your life when there's so many stuff you just adapt and take it for normally. Like this is just how the way it works, and just this is a normal. You don't really have any more stimuli about it because it's your brain works. It just cannot process so many informations to realize your situation. So it adapts, it adapts, it adapts. And that's the short introduction to my video. I hope it was quite clear. The explanation was quite clear. And this was just the beginning, just a simple introduction. Later on, I'm going to go into deep stuff. Talk about this book. It's a huge book and it's full of interesting knowledge that I want to share with you guys, or just share it to myself for myself. Yes, yes, indeed. So, bye. Bye bye.